Hello, welcome back. Now we are going to perform another interesting and debugging practice about HVC assembly instruction. Now what you can see is the two windows. The first panel is the register window and another one is instruction window. So as you can see, the current exception level is exception level 1. Please look at this, ER1H. This means that the current exception level is exception level 1. Then the program counter is indicating this address. At this address, so here is HVC assembly instruction. As you know, the HVC assembly instruction perform two things at the same time. First thing it does is to switch the current exception level from exception level 1 to exception level 2. So here is the workflow from exception level 1 to exception level 2. And the another thing does is to branch to exception vector address. So exception vector address can be calculated based on this convention. That is, the value of the V bar ER2 register will be added to the offset. That offset is 0x400. So if you wanted to the details of how to branch to each exception vector address for corresponding the type of exception, so it is recommended to review the exception vector table. Now, so we're going to run this assembly instruction. Now here we go. Now please take a look at this. Now the current exception level is exception level 2, not exception level 1. Now please look at this. So let me use the r.undo command, the revert last executed the assembly instruction. Now the current exception level is exception level 1. So let me execute this instruction again. Here we go. Please look at this. The current exception level is exception level 2, not exception level 1. And another interesting point is the program counter is updated to this address. So let me copy this address. So this is the address where this program counter is containing. The important question at this point is how the program counter is branched to this address. The reason is the value of the V bar ER2 register is added to this offset. So for more information, let's navigate this menu to identify the value of V bar ER2 register. I will navigate the menu from CPU. Please look at this. Then let me choose Paddle. So let me go to the system control and configuration menu. Click. So let me go down again. So this panel contains the critical system register. Now let's look at the value of the V bar ER2 register. Please look at this. V bar ER2 register hold this value. Let me copy this one. Now here is the value in the V bar ER2 register. And here, this is offset that could be added to the value of the V bar ER2 register. So 0x400 is offset for the synchronous exception by running HVC assembly instruction. So we can find out this rule by looking at the exception vector table in Armv8-A data architecture. So here is the calculation to determine the exception vector address. As a result, we can have this address. Here is the address of exception vector address. This address can be seen in the register window. Please look at this. Now let's revert last executed HVC assembly instruction. Here we go. Okay. The program counter is rolled back to the previous state. Now let me execute HVC instruction again. So at this point, Please pay attention to the parent counter icon. Here we go. 1, 2, 3. Please look at this. The parent counter is updated to the exception, the vector address. Here is how HVC instruction works in the Linux operating system. So every time you look at HVC assembly instruction, so I want you to think about the two things. First thing that Armcore does is to switch the exception level from exception level 1 to exception level 2. Then the parent counter is jumped to the exception vector address based on this rule.